Tomku. All right. So it's 1400 hours, and I guess we can start right now. Okay, so I have a real privilege to introduce today's speaker, Agata Kołodziejczyk, Dr. Agata Kołodziejczyk, one of the most influential Polish scientists, a very unique person, a former employee of European Space Agency, right now working at Krakow's Technical University. Is that how it is in English? AGH. One of the team, I think not only a member, but also a leader of the team that made one of the Ignis experiments. And of course, the force behind the Analog Astronaut Training Center, based here in Poland. That is something that we're going to all hear about right now. A very unique institution, let's say, that already give us lots of data to work on and brought up many astronauts, of course, analog astronauts. But before we send all those people to Mars and to Moon and even further, we need to train them here on Earth. So right now I'm giving you Agata Kołodziejczyk. So have a great time.
Thank you, Ewelina. It's also my pleasure to be here in the heart of Polish space research. I don't remember when I was last time here, and now I see how much more projects are demonstrated here in the main corridors. And I'm really proud. I'm really proud of our Polish sector, of Polish scientists, engineers, that we are really struggling to be in this hard part of work in the front of technology development. My dream, I would say, was to develop bioastronautics, and today I'm going to speak about what I managed to do in the last 10 years. As you can see on this slide, the main part of the project was focused on humans, on people, on communities, and my goal was to network, to work with people from all around the world in order to develop human spaceflight research. Actually, you may see on the map of the world that more and more analog habitats are evolving because we are standing just in the beginning of a very interesting era, which is called new space for commercial astronautics. And many people, they feel that if we don't start training now, we may never fly to space. Times are changing, flights are cheaper, more and more commercial space stations are planned to be launched on the orbit and further, even on the Moon in the future and on Mars, hopefully. So here you can see how many people are interested, in fact, in training, in preparing for commercial astronautics. This until now is very hermetic, is very political, and nearly impossible to be an astronaut. Even if you win the competition, if you became one of the best, still you have completely no chance, no probability, no, I would say, assurance that your dreams that you will fly to space. It depends on so many people, hundreds, thousands of people. But now times are changing. What is changing? We try to create and to push from the bottom development of bioastronautics in a way that it is accessible. So here in Poland, I'm proud to say we are #1 in development of simulators for analog missions. It started in 2016 when I was working at European Space Agency in Advanced Concepts Team. And the main purpose why I did it, why I asked some friends, I found investor. Why all started? It was because I was working on concepts and I needed to experiment in a real simulated environment, because theory is theory, yes, you need to check it. And the cheapest way was to build the habitat. The chronobiological chambers that were available at this time in Europe were completely above any possible, budget line. I couldn't afford for anything. So I realized that the cheapest way is to just sacrifice some of my private money, ask investors to add some money, and to build it in Poland. Why in Poland? Because here we had our lands, yes? Because you cannot build in space, you need to build on the land. So it was already something to start. The first base, unfortunately, was never used, besides one photo that you can see here. We moved the base to Piła, where maybe you heard about Lunares habitat, which is now operating. It is, I would say it is really developing nicely. In this habitat, I was responsible to start everything in Piła, together, of course, with my team. And I managed to organize few missions before I left. So there was habitat set in the north of Poland, but it was easier for me as a mother of 4 kids already to operate habitat in south of Poland where I was living. That is why I sacrificed my house. 100-year-old wooden house, which is completely not a Star Trek like in infrastructure. But I wanted really to do research. I wanted to continue this what I started. I couldn't continue this in Piła. It was logistically impossible. And in this very tiny wooden house, I managed to organize now more than 100 missions. And today I'm going to show you results that we obtained, what kind of databases we created, what kind of data we have, and what is next. Finally, we realized that after 100 missions in this confined space, we need something more. We need again to do something completely game-changing in the world. And now we built, still we are in the construction phase. So when I'm not here, I'm building the habitat by my hands, not by companies. And we are building the habitat to simulate colony, analog colony on the moon and on Mars, and putting us completely top #1 in the world in this kind of simulations. What is our vision? First of all, don't think that we get money from anybody, only from private participants, analog astronauts that come here. These people are our sponsors and investors. They are contributing in development of human spaceflight, and we are very grateful for them. Thank you all. Because with these people who can invest to participate in the mission, these people are completely different motivation. They have completely different motivation. And we want this kind of people with this mindset that if you want something, you are fighting for this. You are not waiting until somebody will bring you on the plate. And in this mindset, I know that this community can do a lot to this planet and maybe further. We want to bring astronaut training for everybody. So we have disabled people. We have everybody who thinks will manage to stay in isolation in the mission, in the habitat, and to follow the rules. We provide practical activities in extreme isolated environment. It's kind of cool because we really like to create spaces that can be used as a scientific instruments. So the whole habitat is a scientific instrument. It is delivering a special type of, like a stimulation, a specific type of it is inducing specific type of activity and sleep phases and so on. You will see in a moment. So the main aim is to access bioastronautics education at all levels, because there are no bioastronautic lectures at school. I just started winter semester first time bioastronautics course at AGH University of Kraków. I brought many books from bioastronautics. I brought many signed books by astronauts. And I'm telling them that this is my dream. I finally teach what I really wanted to do, bioastronautics, and I will share with all my books, with all my autobiographies of astronauts and everything what they experienced. And we want also to do some research. It is very hard to do research, but I can tell you that we can, even in this restricted area, run research on adaptations, short-term adaptations, not long-term, because all our participants, they cannot afford to stay 1 year in the habitat. Nobody is paying them for this. They need to take some free days from their jobs. So we only can allow this. We can also test quality of performed experiments, allow them to develop, to be creative, and to completely change their mindset, to leave their comfort zone. What are the procedures? Of course, nothing would happen without procedures. We need to know what we are doing, yes? And especially in the habitat, very important for us is to plan the mission. Not only one mission, we need to have the whole strategy for all missions. Because, as I tell you, we are not funded by any grants. We are not funded by any research institutions or sponsors beside Analog Astronauts, so we need to plan this very carefully. And we are working all together, I must tell you. Many people, they ask me, Agata, I would like to write a procedure. I would like to write a documentation. Can I do this? And then I'm very happy, even more than happy. I'm giving them literature, professional one, and we are developing these materials. So each crew, before they enter the habitat, they receive mission manual. That is a document specially prepared for their analog mission. And they need to familiarize with safety rules, procedures, and everything what is related with using the habitat, which I named already a scientific instrument. So this is a brief instruction of what you can do, what is dangerous, what can make you not in a good state, and it can be dangerous also for the rest of the crew. The communication, we also communicate with the crew before the mission. 1 month before the mission, we start the kickoff meeting. All crew meets first time, and we set up the signal channel dedicated for the specific expedition. Yes, so you can see here how many different expeditions we have on our signal channel, and we can compare the communication. This is our black box of the mission. The communication is not verbal because we have people from so many countries. They have so different accent. Very often we had many misunderstandings, and sometimes it was very dangerous. So at the end, we decided only writing communication black on white, because then we really understand what is going on. There is only one communication officer on the analog astronaut side. There is only one Capcom on the MCC side, so Mission Control Center side. Before the mission, we want to check our crews, how they adapt to stressful situation. So we have a collaboration with a cryotherapy institution in Kraków, where we insert our analog astronauts before the mission, and we measure how they react to kind of extreme situation, which is walking in minus 120 degrees of Celsius, nearly naked, for 2 minutes. It is interesting for them. It is very new. We always ask, of course, if somebody already had cryotherapy. And once we are ensured that nobody has been trying this, even knowing this. This is great, and we are analyzing these signals. We also are running several astronaut selection tests, something like this, to show our participants what kind of questions are asked during the real one, recruitment process. Our habitat is full of sensors. We need to monitor environment, and this is the main part that we need to do because we are controlling the mission remotely. And because of this, our Mission Control Center needs to know as much as possible about what is happening inside. The infrastructure is very small. You can see the modules. We have bedroom module, clean laboratory with MESA, then we have geolab, shelter, and gym. In all these modules, we have, of course, camera monitoring beside hygienic module, the toilet, and we have several multifunctional sensors to measure temperature, pressure, CO2 levels, to measure humidity levels, to measure noise levels, illumination, and power consumption. Here, just to show what we reach during each mission. And remember, we made already 100. So we have a huge database with several beautiful parameters and oscillations, how crew is influencing internal environment of the isolated habitat. We designed this habitat in order to see these oscillations. So you cannot, of course, open the windows. You cannot increase the ventilation tempo. You need to follow the procedures in order to get decreased or increased parameters which you like. Here you can see our main screen that Mission Control Center can see, this black screen with several colored blocks and graphs and diagrams. We have very simple code. When something is green, it is nominal. When it is not green, not nominal. And depending what is the scale, so coming to yellow, orange, red, it means that it is increased value. And if it is blue, it is decreased value. Of course, the system is connected with our small neuronal network. So we have some alerts when maybe somebody is not seeing actual situation, what is happening in the habitat. You can see that several parameters strongly affect the environment inside. And this is very interesting for us because we want to develop life support systems. In the future, especially we want to develop bioregenerative life support systems. I believe that Poland, we can be a leader of development of such technologies. We have enough data. We have already a huge understanding what is happening depending on what type of crew is entering the habitat. We monitor the water levels, we monitor illumination, we monitor even the body temperature of our participants. Daily mission operations. Well, crew scheduling is critical to sustain nominal parameters in the habitat because we cannot put all the crew in one module. Then the CO2 levels will grow up too high. They will be more than 2000 ppms. And this starts to be maybe not dangerous, but it is not comfortable for our participants to stay in such environment. They suffer from headaches, from lost focus, concentration, and of course they may have problems with sleep. So crew scheduling is a critical parameter here. Then I will go through what we do with extravehicular activities, scientific experiments, habitat operations, so maintaining life support systems, power, water recycling, and waste management. So there is no possibility, even like on ISS, that our analog astronauts can throw away wastes from their habitat. They live with their wastes for whole 1 week. So we have a special procedures for everything to keep the crew safe. And of course, in order to do this, health monitoring, non-invasive health monitoring. Often, of course, we are collecting their blood, but then we need to have in the crew medical doctor, yes? And of course, this needs to be done extremely sterile, because these conditions in the habitat, even we monitor microbial purity in the air, still we see that depending on who is coming in from which continent, we have very huge disbalance in microbial life inside the habitat. So the evolution of our mission schedule. In Lunares habitat, when I was still there, and in the beginning of our missions in south of Poland, the schedule was kind of dynamic structure. Everything was on the Google Drive, and you can see here 4 analog astronauts. They have for every day a different schedule. Of course, they have colored activities to make them easier following what is happening. You can see that there is, I didn't put hours, but at this time we scheduled everything according to UTC time, similarly as on ISS. And on the left side, there were some daily, the most important experiments that our analog astronauts needs to perform so they don't forget. And on the right side, there were some emergency procedures sent by Mission Control Center. Please, guys, do this for us now because somebody wants this. So there was this right side of the schedule available for Mission Control Center to immediately add some new task for the crew. But it was quite hard to repeat the same pattern of activities, the same pattern of behavior of the crew using this old type of schedule. So we standardized the schedule. Depending on how many people in the crew we had, we used to have always the same pattern. And this was much easier for us to follow the habitat environment, the health of the crew, and all procedures. So here you already can see that we changed the UTC time into mission time. When our crew was waking up, no matter when they woke up, they set all watches to hour 0. And this was their day starting from hour 0, and they ended the day hour 16. For many people, it was kind of weird, but it worked. For larger crews, because as I mentioned, we are the first in the world who did the analog colony simulation for 30 people in isolation. Then the schedule was far more complex, and we just started to work on that, to think how to manage such many people in a habitat so nobody is disturbing each other. And yeah, it was really tricky, really interesting task for many people sitting here and designing the mission. So here you can see again the mission time 0. We start our mission day from hour 0, but here we divided everything for like experiments, and each experiment was performed during the day by each crew or by specific part of the group. And I don't have this, but what you saw here for people, yes, so it is one column for one person, for commander, communication officer, astrobiologist, crew medical officer, and so on. Here we had the same schedule, but for all groups. I don't know, can I show it on my laptop? You can see the diagram, how many people we had. We had a mission operation team, human operation team, HOT, science team, ST, EDA team, and engineering team. And all the 6 people were treated as one in the schedule. So because of that, we could spread them in different modules. So they were working together. Nobody was disturbing no one. EVA procedures, of course. Nothing happens from zero. We were inspired by already existing papers for EVAs. There are many materials to design really good EVAs, and you need to of course to consider what kind of equipment do you have during your EVA. In our case, we developed our own EVA suits, which we think they are quite good. They are pressurized, but for this mission, we didn't use pressurized function because we were afraid of too many risks. There was not enough time to train the crew how to use the suit. But we asked people who already developed EVAs in different analog missions to come and work with us. And they developed several protocols and procedures how to perform safe EVA and, of course, efficient. This photo comes from our first EVAs in Lunares habitat. From this time, we completely changed, I think we completely raised the level of our EVAs. We have whole crew, as you saw, 6 people are operating one EVA, and 2 people are performing EVA. Sometimes one person can also perform EVA, but for safety reasons, we are always trying to have 2 people on EVA. And now our EVAs are testing in analog conditions devices that in the future will land on the moon. So we are very happy that we got this professional kind of level. And here you can see the manual. Of course, we have manuals for each used equipment that we are using during the mission. These suits were developed in collaboration with Professor Cameron Smith. He's an anthropologist making these suits physically, and we are just telling him what we would like to obtain. So this is a Polish-American collaboration. Then communication and mission control. Very often our mission control is only me, or sometimes I ask students who want to do their engineering thesis, master thesis, or even doctoral thesis. We had some cases like this, and then they are collecting some data and they use them for their research. The data is transmitted via a signal, as already you saw, and via our internal Google Drive. Unfortunately, we don't have yet a special platform. I mean, we have it physically, but it is too difficult to operate by new analog astronauts that we have no time really to train them how to use our operational system of the habitat. So this is kind of a bottleneck that we cannot perform things beautifully. We need to use the most simple tools in order to facilitate, to speed up the tempo of training before the mission. But it works. It works and people are satisfied. This is the most important. So you can see that we have several protocols, emergency communication protocols. Here you see one of my students was preparing such document. I have plenty of them because this is one task that I ask my students to do. Of course, we have instructions for each device, but I don't want to show you in details what is the instruction. It is maybe not like IKEA instruction, kind of more specific, but still everywhere, everything is described. This is our habitat. It maybe doesn't look fancy, as I tell you. We are not architects. We are not interested in a beautiful visualization of space architecture, but we are interested in stimulation. stimulation of specific stimuli, like light, for example. Here you can see it is dispersed. We are interested in confinement. So we try to decrease the space that is available for our analog astronauts, and we ask them to live in such a very, very confined space. So this is important. We develop several solutions for experimentation process. So we need to occupy our analog astronauts. So they are never bored. They need always to do something from the morning to the end of the day. Here I will show you some examples, what we are measuring and how we are measuring. Together with QLab company, we developed a special sunlight simulator system, which we implemented in the habitat. Here you can see the spectrum of this lighting system. We had a special controller, so we could manipulate between intensity and type of light frequency. So what we had UVB light, UVA light, we had infrared radiation, and of course visible light, which was the most similar to the sunlight. We tried to find this kind of LED diodes. And in these experiments, we asked 2 crews to enter the habitat for a very long time. So they were entering the habitat for control conditions, like a normal light without UV, without infrared, for 2 weeks. So 1 crew 2 weeks, another crew 2 weeks. And then there was experiment with added infrared radiation, plus, of course, visible light, another crew, and then we added ultraviolet. So in total, each crew spent 1.5 months in the habitat. Why they were always entering the habitat at the same time? It was because we had some women, and women, you know, they have a menstrual cycle. We didn't want to have any influence of hormones on their behavior inside. So it is really far more complex than you think when you organize such missions and you want to get relevant data. Here I only show you the levels of CO2, but you can imagine that we have levels of light illumination in each module. We have information about their circadian cycles, and in a moment I will show you even more. So we have a lot of data from each mission. So here you can see on these colored diagrams 14 days. So each column is 1 day, and then you have a 1 hour resolution what is happening in the habitat. This is particularly for the bedroom module, and this we have for each module. So you can only imagine how much data we have from only 1 experiment. This is not all, of course, because we measure their cortisol levels, their melatonin levels, their serotonin levels, even testosterone. You even can imagine how many samples, how many analyses we had to do. Fortunately, for this, we got a grant from QLab, so we could allow to do some research on the amount of hormones in the blood, in saliva, and in blood, in saliva. Yeah, here I'm showing you only this one. And urine, thank you. Yes. Then another experiment, which I think is interesting for future studies and possible collaborations, is our specific condition in the habitat that we have only 1 air input, fresh air input, and we have a bunch of ventilators and then pipes that are removing CO2 from the habitat modules. Because of this kind of situation, we can observe, very well known, by the way, cycles of our oxygen consumption and CO2 production. It is, of course, proportional, correlated with our metabolism during the day. We can observe siesta. Maybe here it is not visible, but we are analyzing many crews. And we are analyzing how crew composition, if you have 4 people in the habitat, 5 people in the habitat, 6, different gender, different crew dynamics, how this affects CO2 levels, everything, in order to build in the future digital twins, a model of how the crew behaves in the habitat in specific conditions. Of course, we monitor their sleep, their activity. We try to correlate this data with what is happening with CO2 levels. Here you can just see a bunch of type of distributions for several missions, how humidity parameters are distributed, how noise, what is the noise level in the habitat. We try to simulate International Space Station, but I learned yesterday that we are too silent. We should be more loud. So we need to bring more machines that are making bzzz and so on. Distribution of CO2 during each mission, you can see the variation, which is really interesting. We want to know why it happens. What is maybe the algorithm, how you can model, how you can predict, how you can build some future alerts for our crew, and especially to combine this with a real bioreactor. So algae, please produce more oxygen because now crew is entering the gym, yes? Something like this. Another very interesting experiment which we are doing is, of course, collaboration with Collegium Medicum at Jagiellonian University, where we are doing something super interesting, how our microbiomes are exchanged in isolation. So how you and me affect each other from this microbiological side of us. We are hybrids, yes? We are not only the humans. Our mood depends on what kind of bacteria we have inside our body. So we tested microbiomes of respiratory system. We collected samples from nose, from throat, and from guts. We collected them in the beginning of the mission, during the mission, after the mission, and we tried to understand the dynamics, what is happening, why we want to do this. Because we think that we are very close to establish the guidelines of biosafety for space habitats. We need more data, and we are now developing and creating a new colony mission for 50 people crew. Again, game-changing experiment for the world. And we want to repeat our research that already have very, very promising data. We observe that our microbiomes can be very weak or can be very stable, and it depends on people. And in isolation, something happens that some microbiomes can be invasive for some people and can cause very dangerous situations. Here on the right side, you see that this experiment was performed in larger habitat. We have here already 300 square meters, comparing to small habitat confined 57 square meters. In this area, we collected microbiological samples. We ran several analyses, including microbiological analysis and genetical analysis. And now our bioinformaticians are still processing so much data. So I hope at the end of the year, we will have a publication about this amazing and super interesting study. Of course, whenever it comes to conferences, we try to be everywhere. We try to communicate what we are doing. During actual International Astronautical Congress in Sydney, we presented 8 papers and 8 different types of research. They are not yet ready, matured to be published in open access, but we are repeating, and trying to get the best result and the value to this research. Here you can see my student. I'm honored to be a co-supervisor of her doctoral thesis, and she was presented her experiment about using VR technologies in isolation, how to cope with some behavior at this level. Again, soon we will have very nice publications. We have special tools and devices which we obtained, we bought from possible, sources like this 3D gyroscope. And we try not only to train our analog astronauts on this gyroscope, which is a very cool, very, very nice practice. Everybody wants to do this. But then we also try to use even this simple method already to teach our students how to collect repeatable data, how to decrease the errors, and so on. So we really learn a lot during this kind of experimental part. As I mentioned, we try to standardize our missions because we need to increase statistical power. What we have actually now in analog missions, we have data from 6 astronauts, maximum 8. This is completely not enough. So I understand that people are not really treating this as a real science. We need to raise the level of analog missions and show that you can do real science on that. So we have several standardized parameters that we collect on each mission, and this is really nice. Here, for example, we can see again several missions and how, what is the water balance? So how much average per day per person they drink water, how much average per day per person they urinate. And because of that, we wanted to have this data because we want to develop a bioreactor that is purifying the water out of urine. So we wanted to know how we need to tune our instrument in order to manage all conversion and purifying the water. Creativity. In our habitat, it is very easy to be creative because we don't have everything on plate. Sometimes something is broken. And our analog astronauts, they say, MCC, what we need to do? We say, be creative. You have so many devices there, so many tools. Try to do and operate how you would do on Mars or Moon. We are trying to design and test several materials. We have a special part of the module that we can do this. We have vacuum chambers. Of course, these are simple. These are not super professional. But this is for learning procedures, yes, for learning some techniques and methods of using devices, and later on to do more and more advanced study. In the habitat, we created sustainable ecological biomaterials. We can do this in isolation. We don't need to ask any Amazon or eBay to bring some extra substrates to produce this. Everything is in the habitat, and astronauts, they really enjoy to do things in situ. Architects, they are coming and they try to make this habitat bigger by using several illusions, several projections, which is very interesting study. Later they present this on exhibitions, on conferences, seminars. We work with several simulant regolith samples. We try to produce food in this confined environment. We try to see what is the microbial contamination, because we had a lot of this, and we wanted to see how this influenced the crew. We try also to sustain sterile conditions. So we have several methods. Here maybe you don't see, but sometimes even astronauts, they used something that is completely not permitted in the habitat. So they used open fire in order to sterilize the local air, and they seeded some bacteria. but yeah, we need to improve, I know. We still need to develop new devices to the habitat, new equipment that will allow people, like glove box, for example, would be great, to allow people to do what they really want to do professionally. We even had the construction of CubeSats inside the habitat because we have all electronics there, not all, but all basic electronics, microcontrollers, we had sensors, we have the wires, of course, soldering stuff, oscilloscopes, power sources, all multimeters, everything is there. And biology, because I'm biologist, so for me, more closer to my heart is development of biological experiments in such environment. And I think that this I can teach better and more my students. So for example, here we are collecting happy, sad, and other type of tears, because we know that tears, they have different chemistry, biochemistry, depending what is the source of their induction. As I mentioned, the habitat is not perfect. I would say even it is terrible. It is terrible, and our analog astronauts needs to somehow survive there, sustain everything operational. So they are sometimes repairing, sewing, teaching. Very nice. They are working with animals. Some people, they hate, for example, cockroaches. We ask them to eat them, and not everybody is really happy about that. But sometimes, yeah, they even make friendships, interspecies friendships between cockroach and human. I was mentioning many people are coming to test their prototypes to understand how their developments, in technologies, how they work in isolation. So we are very happy to host these kind of researchers with us. And I don't know how much time, I know how much time I have. Illusions, yes, analog missions are simulations, yes. We try to insert the brains of our crew in some kind of illusion. So they believe that they really are somewhere outside the planet. And because there are no windows, because there is no time reference, it is quite easy to obtain, especially working with materials that are professional, used by other space agencies. We have emergency procedures, of course. There is a lot of documentation that our analog astronauts needs to familiarize either before the mission or during the mission. And of course, after the mission, we have a huge debriefing, summarizing all experiments, all the mission data that we obtained. Was the mission successful? Was it not? What could be better? Everything we try to wrap up and to present it in a nice, friendly way. So when we say about emergency, I just wanted to say simply a few words. It is not a simulation that we are, displaying on the screen that the CO2, for example, is high. It is really high. So we try to make a simulation when there is a real elevated level of CO2, and we even try to induce even higher. They have 20 minutes of time to do some task, and then they can switch on, for example, the life support systems, which is ventilation, for example. What kind of tasks? Well, also when they need to observe space weather. So sometimes they have a magnetic storm. They have problems with communication with Mission Control Center because satellites they must to be reset after some proton shower. And they need to measure the radiation levels using, equipment that is available in the habitat. We have plenty of them. And this is the last thing, simply what I wanted to say. As I mentioned, I invite everybody to collaborate with this huge analog colony mission with 50 people on crew. The habitat is now under construction. I mean, we are increasing the number of modules. We are increasing the number of bedroom chambers. So this is just visualization, but we hope to make this kind of beautiful chambers for everybody, 50 people. Again, private investment. It is because we had really big success during our colony mission. Nearly everybody wants to come back and participate in this another, the largest analog simulation in the world. Beside analog missions, we are organizing a lot of activities for young people, like junior space camps, and we were even published in Science because of that. We are organizing rocket workshops, stratospheric missions. So, and the education is really important for us. We are happy that many people are coming to us and they want to write their engineering thesis based on some developments in the habitat. So it is like a mutual symbiosis. They are helping us, we are helping them. And the end, I wanted to invite you to watch on YouTube, no matter when you have time. We start 3rd of November, our Analog Astro Conference, which will be available on YouTube, as I told you. Whenever you want, this will be our histories, careers, and what happened after these analog missions. Lessons learned after 100 organized analog missions. We want to show personal achievements, published papers, defended thesis, developed technologies and startups, and then obtained grants, because now finally we start to get money for better and better research. With that, I would like to thank you for attention, for being with us, and welcome to collaborate.
Okay. Thank you so much, Agata. It was, as always, amazing and unique. From my side, I can say that that your habitat is truly magnificent, although quite, let's say, a rough one. And all the things you're doing there, it's really amazing, especially, of course, the junior space camp. But I'm not the one who should be talking right now. Are there any questions, perhaps from the floor?
I have one question only. So how to play with the different gravity coefficient? Probably one of the first habitat will be at the moon surface. How to simulate this? What you plan?
Our idea is not simulating exactly the lunar gravity, rather to simulate altered gravity and how this affects human body in a short-term adaptation. We know a lot already, but we try to find new biomarkers, how we can non-invasively monitor these adaptations to altered gravity conditions. And this we can do already using our 3D gyroscope. We have plenty of volunteers who want to train and who want to hang with a head down for many minutes or with a different angle of gravity acting on their body. But of course, this is not only place where we can simulate altered gravity. We collaborate with Military Institute of Aviation Medicine here in Warsaw, where they have a human centrifuge, and we also try to develop long-term projects with them. Now we have short-term projects. So analog astronauts, they simply come, they test the centrifuge and their bodies in the centrifuge up till 4.5 Gs. Sometimes they test their adaptation to microgravity, and that's all. But we definitely need more studies. We need to develop more stable collaboration, and of course this needs to have some grant, because we have no money for this very expensive device.
Okay, anything more? Okay, so perhaps from person at the, no, I'll just check the chat. Oh, impossible. Right, okay. So if there aren't any questions, I would like to thank you very much, Agata. It was really amazing to see all what you've done for those years. So I'm crossing my fingers for your luck to make a lot of new materials, take new data. And of course, if you won't mind, I would like to get the YouTube channel of yours so we can share it on our social medias that you're doing the type of conference.
Thank you very much, Evelina. Definitely, I will post you the link.
Wonderful. So, Agata, thank you very much. Enjoy your day, and I hope see you soon.
Thank you, everybody, and hope to collaborate.